one and all. This is Kannan Saipriya from BSc MPC final year from SRR Government Arts and Science College, Autonomous, Karnataka. Now my team members are N. Ashwini, S. Nandini, T. Srija, S. Mayur, and we have performed the student study project of Jignasa 2025 entitled Comparison of Different Pendulums, Error Analysis of Acceleration Due to Gravity. Our supervisor is B. Raju, Department of Physics, SRR Government Arts and Science College, Autonomous, Karnataka. Outline of the presentation: Introduction, aims and objectives, literature survey, research methodology, and experimental method. Simple pendulum, compound pendulum, torsional pendulum, observation, analysis, and finding. Conclusions and references. Introduction. This study entitled Comparison of Different Pendulum Error Analysis of Acceleration Due to Gravity investigates the determination of gravitational acceleration using various types of pendulums including simple, compound, and torsional pendulums. The acceleration gained by the objects due to gravitational force is known as acceleration due to gravity. Gravitational acceleration or acceleration due to gravity is a vector quantity and it is indicated by g. The value of gravity on the earth is 9.8 meter per second square. The importance in measuring the acceleration due to gravity is to understand the structure of solid earth and ocean circulation, meteorology, geodesy and geophysics, motion of planets and satellites, motion of objects, uncertainty of pressure measurements, etc. Instruments to measure gravitational accelerations are gravimeter, Edward machine, different pendulums, freeform method, etc. Aim and objectives. Aim to compare the performance of different types of pendulums in determining the acceleration due to gravity, and to analyze the associated errors to identify the most accurate and relevant method. Objectives: explore pendulum types, determine gravitational acceleration, error identification and analysis, compare results, conclusions. By addressing these objectives, the study aims to deepen understanding of the principle governing pendulum motion and analyze the accuracy of classical methods in determining gravitational acceleration. Literature survey. Simple pendulum studies. Numerous reveal that small angle factors such as temperature and material fatigue give experimental setups for the torsional pendulums have been found to be prone to damping effects necessitating corrections for accurate results. Research methodology and experimental method. In this project, we have taken different pendulums to measure gravitational acceleration. These pendulums do simple harmonic oscillations due to gravitational field. By calculating time period of oscillations and pendulum lengths, we can calculate gravitational acceleration. Now, my teammate Ashwin is going to explain the simple pendulum.
A simple pendulum consists of a point mass m suspended from a fixed point by a string of length L. When the mass is displaced from main position, it oscillates about the main position vertical plane. The relevant parameter that describes this oscillation is known as the period of oscillation. The period of oscillation T is the time required for the pendulum to complete one cycle in its motion. This can be determined by measuring the time required for the pendulum to reoccupy a given position. As shown in figure, m is the mass of the pendulum bob, g is the magnitude of the gravitational acceleration and L is the length of the string. M, g and L are positive constants. A real pendulum oscillating with a small amplitude may be described as a simple pendulum if the following two conditions are met. The length of the string L is much greater than the size of the bob. In this case, the bob can be treated as a point mass located the center of gravity of the bob. The mass of the string supporting the mass is much less than the mass of the bob. The period of the pendulum will be given by the following equation. Time is equals to T is equals to 2 pi under root of L by G. Solving above equations for Gx. G is equals to 4 pi square L by T square. The period of the pendulum can also be found experimentally by following equation. D is equals to T by N, where N is the number, the time period T and 1 by T square. G is equals to 4 pi square L by T square. G is equals to 941.31352 centimeter per second square. Error 38.683648 percentage is equals to 3.6476 percentage. Now my teammate Nandini will explain about compound pendulum.
Compound pendulum. A rigid body with distributed mass able to freely pivot about horizontal axis which does not coincide with the center of gravity is called a compound pendulum. Compound pendulum is used to measure the gravitational acceleration. A rigid body which can swing in a vertical plane above some axis passing through it is called a compound or physical pendulum. In figure, a body of irregular shape is pivoted about a horizontal frictionless axis through P and the displaced from its equilibrium position and angle theta. In equilibrium position, the center of gravity G of the body is vertically below P. The distance Gp is A and the mass of the body is M. The restored term to perform a compound pendulum. This is the graph representation of compound pendulum. This is the table of observations which we done on our laboratory. And from the graph, I is equals to 65 centimeters. Time period for 65 centimeters is 1.7. The value of gravity is equals to 4 pi square L by T square is equals the total gravity 995.288 centimeters second square. The error 15.288. The error percentage is equals to 1.56. Now my teammate is going to explain comparison table and conclusion. Thank you.
The comparative table of simple pendulum and compound pendulum is the average value of L by T square of simple pendulum is 24.0131. The compound pendulum is 25.3906. And the gravitational acceleration of simple pendulum is 941.31352. And compound pendulum is 995.288. The error of simple pendulum is minus 36.686. Compound pendulum is 15.288. The error percentage of simple pendulum is 3.6476. Compound pendulum is 1.56. Conclusions. After conducting experiments, performing calculations and analyzing errors, it is observed that the simple pendulum, while easy to use, is less accurate due to limitations such as small angle approximation, sensitivity of length measurements, and air resistance. The torsional pendulum, although capable of providing high precision in certain cases, is generally not recommended for directly measuring gravity due to its complexity and the requirement for varied measurements. In contrast, the compound pendulum is typically the best choice for accurately determining the acceleration due to gravity. Its ability to accommodate different mass distributions and offer a more flexible experimental setup makes it more accurate than the simple pendulum and more practical than the torsional pendulum for this purpose. Furthermore, the compound pendulum versatility and adaptability allow for calibration, enabling greater precision across a wide range of experimental setups. Thank you.